So if you want to find complex numbers between 19 and 19.01, so now maybe let's see what's the difference between 19 and 19.01. Who can tell us the difference between 19 and 19 point? Yes. Okay, it's 0.01, right? So what you can do is you are moving from 19 to 19.01. So you find that, so want numbers which are between this. So 19 point, so what number is, you want numbers which they should be bigger than this. If you get a number line, take a number line like this, where you've got 19 there. Let's say 19.01 is here. So for a number to be, it should be bigger than this one, but smaller than that one. Okay, just give me one example of a number which is bigger than 19 but smaller than 19.01. Just any example of a number. 19 point what? 19.001, right? So you can write those so you can have 19.001. So we have got two zeros here, and then 0001, and then 00001, and then 000001. So there's no proper pattern here. Remember, a rational number is a number that is repeating and it has got a proper pattern. Now this one has no pattern. Okay, like the numbers are not repeating themselves. If you see, you have got two zeros here, you've got three zeros here, you've got four zeros, you've got five zeros. So the pattern is not repeating, and the definition of an irrational number is a number that is non-repeat and non-terminating. So this number, you put three dots like that. If you don't want to write such a number as in this form, you can have something that has got a root. So get something, you've got 19.01 and also 19. So give me one example of a number that is bigger than 19.01. 19.02, right? Okay. So what we are going to do is we are also going to multiply these two numbers. So we have got 19 times 19.01. So just try to multiply those two numbers, 19 plus 19.01, and then try to take their root. So it is a number that is between these. So if you multiply these two numbers, 19 and 19.01, so what you are going to find will be an irrational number which is between these two numbers. And also, because we are talking of the difference between these two numbers is 0.01, you can subtract this difference to the product there. It will also be between there, and you can add the difference. It will still be between these two numbers. You can try that if you have got your calculator with you. So that is how you can find irrational numbers between two numbers. So you can either take that form where they are just repeating. Remember, an irrational number can be a non-repeat and non-terminating. That is an irrational number. But if you have a number 2.1, let's say 8.1, 2, 1, 2, 1, 2, 1, 2, this is a rational. For something that is irrational, it is then is 1.12, 112, 1112. It is not repeating. This is irrational. This is rational. Okay. Any other? Yes. You see that that number is between. It's between 19 and 19.01. Isn't it? So, yes, you want to have calculators. So, I think the product is not difficult. Multiplying these two numbers, you can multiply without a calculator. And then subtracting a 0.01 from. Pardon? Alright. So we can go on other questions. Perhaps they are past paper questions and okay, you can go on. Okay, go on. Uh-huh. The cube root of 2. Alright. Now, if this was 7 over square root of 2, rationalizing, we would have just multiplied by root 2 on top, even down root 2, isn't it? And that would have given 7 root 2 over 2. Right? Now, this is a cube root. Now, when you are talking about a cube root, what you want to ask yourself is, how do you cancel the root on a cube root? Okay. The reason as to why we are multiplying root 2 by root 2 is we know that root 2 times root 2 will give us root 2 squared. And this will cancel out. Okay. So that is the aim as to why when we are rationalizing those two, we are going to just multiply with itself because it will be squared. Now you want this one to become cubed. Okay. So what you want to make sure is you multiply with something that is going to make these two to be cubed so that it cancels with this cube which we are seeing that side. Does anyone have an idea? What should we do to make this 2 which is here to be cubed? What should we do? Yes, go on. Okay. Uh-huh. Yes. So now what you want to multiply with is the cube root of 2 squared, which is 4, even down cube root of 2 squared. Remember, if you say cube root of 2 squared over cube root of 2 squared, this is the same as 1, and 1 doesn't change anything really. So if you multiply this portion with this portion, you can multiply those which are on top. What you are going to get is 7 multiplied by the cube root of 2 squared. And then down, what you are going to have is cube root of, okay. So what is inside is going to multiply 2 by 2 squared. That will give us 2 to the power 3. So and then what we are going to remain with is 7 cube root of 4 over Mr. Bishonga. Mr. Rushomo is where? Your laptop is confusing. Is it on power? Alright, so what do we get down if we multiply these two? Are you able to get me? The laptop misbehaved. Alright. Now what we are going to do is we are writing the cube root. Just multiply those things which are inside. Okay? Oh, we already did that. Sorry. I'm repeating the same thing because something happened. Okay. So what we are having is 7 cube root of 4 over 2. So in this case we've rationalized. So this can also be written as 7 over 2 cube root of 4. To make sure that this 3 doesn't look like it's multiplying, we better put in the brackets. Is that fine? Alright. Are there other questions? We go on. Yes, go on.
How can we express this 5 over I
5 over I
minus 20 over I raised to the power 18,
20 over I raised to the power 18,
then plus 4I raised to the power 3.
4I to the power 3.
Actually, the 4 is in brackets. That means this.
It's like this?
No, the 4I is in the brackets.
Or like this?
Minus, yes,
Minus
minus the root of negative 25.
root of, is negative inside?
Yes.
Okay. We want to express in which form?
Then we are going to express that A plus BI.
A plus BI. Alright. So for this one, what we want to do is first we simplify that, even this and these terms. So now let's simplify them. Now the first thing, of course, we know that I to the power 2. What is I to the power 2? Negative 1. Okay. Now this portion which we have here, if we multiply everything by an I, so this will be I to the power 2 multiplied by I. What are we going to get? What are we going to get? I squared times I.
Negative I.
So we are going to get I cubed. And then negative 1 times I. Then we get negative I. So I to the power 3 is the same as negative I. Is that okay? Do we get that?
Yes, yes.
And then at this stage, let's square this. Okay, we square that. So I to the power 3 squared will give us I to the power 6, right? And that will be equal to negative I squared. That will give us I squared. But we know that I squared is equal to negative 1. Is this okay? Are we moving at the same pace? Okay. Again, we can square this portion. So I to the power 6 squared, that will be I to the 12. And that will be equal to negative 1 squared will be positive 1. So I to the 12 is positive 1. So our aim is to reach up to 18. Okay. So what we can do at this point is, let's multiply this portion by another I. So what we are going to get is I to the power 13 is 1 times I will give us I. So again, if we multiply this portion by an I, we'll get I to the power 14 being equal to I times I, which is I squared, and we know that I squared is negative 1. This one multiplied by an I will give us I to the power 15 being equal to negative 1 times I, which is negative I. Multiply this one by an I, which will give us I to the power 15 times I. It will be I to the power 16, and that will be equal to negative I times I. That will be negative I squared. But we know that I squared is negative 1. So that will be negative 1, which will give us a positive 1. So that portion, instead of writing I squared, negative I squared, we are going to write positive 1. If we multiply this one by another I, we are going to get I to the power 17 being equal to I. And then multiply this by I. That will give us I to the power 18 is equal to I times I is I squared, which you know is negative 1. So this is what we want. This procedure is not necessary, but what you want to know is that I to the power 18 is equal to negative 1. Is it fine there?
Yes.
Okay. Alright. So we know that I to the power 18 is negative 1. So what we have is 5 over I minus 20 over negative 1. So negative 1 will make this portion become positive, and then this will be positive, and then this will be positive 1 down. And we know that 20 over 1 is simply 20. So we simply write this as plus 20. Okay. Having known that I to the 18 is equal to negative 1. So if we substitute negative 1 here, please, at times combining the processes, you got to make sure that what is necessary, you put it when you are solving if such a question comes. So 4 to the third power, that will be 64. I to the third power is what? We know I squared is negative 1. If you multiply this with I, that will give you I to the third power negative I. So that will be 64 times negative I. Okay. And then minus. Now, root of negative 25 is the same as 25I, isn't it? Because we have got a negative inside. Is that okay with us?
I think but the I should be outside.
Okay. So instead of extending this bracket here, this is going to end here. So the I is going to be outside. That is because if we have got root of neg 25, let me show it here. This is saying the root of 25 times the root of negative 1. And we know that the root of negative 1 is I. So that is how it is going to become. So the I is outside the root. Is it fine now? Okay. So this is 5 over I plus 20 minus 64I. Then minus, of course, root 25 is 5I. So this is going to give us 5 over I. Now this 5 over I, let's conjugate it. 5 over I, we conjugate, we multiply on top by negative I, down also by negative I. Remember, if you are conjugating, multiply by what you can see down, but change the sign of the imaginary part. So for this one, we don't even have the real part for the down part, so just do that. So that will be negative 5I over I times I, that will be negative I squared. But we know that I squared is negative 1. So that will be negative 1 times negative, which will give us positive 1 in that case. So the down part will simply write positive 1. And we know that 5 into negative, 1 into negative 5i will simply give us the same negative 5i. So instead of writing 5 over I, we can write negative 5i. And then we can bring also this one which contains an I, that is the negative 5i. Again this one, negative 64i, and then plus 20. Negative 5, that is neg 10. Neg 10 minus 64, that will be neg what?
negative 74i.
So the aim is to write it in this form. So then we start with the real part, that is 20 minus 74i. So it ends there. Okay, is that fine with everyone? Are there questions, or we go to the next question if someone has another one?
Yes, another question.
Yes, go on.
Uh,
Yes.
just a minute. This one says,
Mm.
how do you, how are we going to simplify negative 4
Over.
over the over 3 plus 2 root 2
Like this.
yes plus 4
Yes.
plus 4 plus root of 32.
Like that.
Yes. Then the question is to rationalize the denominator.
Okay. All right. So such a question we've been given. We need first to start with this portion so that we make it in the form a plus b root c. So that portion we don't want to have the root. So let's rationalize the denominator for the first portion. Okay. So let's get, so this will be negative 4 over 3 plus 2 root 2. So we conjugate, of course, when we are talking of conjugating is most used on complex numbers, but for some of you who did additional mathematics, on SURDS we also used conjugating. Alright. So this will be 3. We are going to change the sign there. So that will be minus 2 root 2. Even the down we get the same 3 minus 2 root 2. And then that is plus 12 minus root 32. So if we start multiplying, neg 4 by 3, that will be neg 12. Neg 4 by neg 2 root 2, that will be positive 8 root 2. Now the down part, we can just get the first number here, square it, minus the second number, which is the 2 root 2, also square it. Please, it's everything in the brackets. If you miss out the brackets, you might not find the right thing. So that is giving neg 12 plus 8 root 2 divided by 9 minus. Now what is inside 2 root 2 squared? First we are going to get this 2, square it, that will give us a 4. And then the root 2 squared, that is a 2. Because the root and the squared will cancel out. Then we've got root 32. So we go on simplifying. So that's neg 12 plus 8 root 2 divided by 9 minus 8. Of course, 9 minus 8, let's just follow the procedure first. Now, because we've got root 2 and we've got root 32. we mostly want to make sure that the roots are the same. So is there any means at which we can write root 32 with a 2 in it? So in other words, what number should we multiply with 2 for us to get 32? So 32 divided by 2 will be what? 16. And we know 16 is a perfect square number. So the root of 16, so we can split this as root 2 and root 16. So that is the same thing. And we know root 16 is 4 and then root 2. So that portion, instead of writing root 32, we are going to write 4 root 2. And then this will be negative 12. Of course, 9 minus 1 will just go out. And then we can bring now the positive 12. Okay, let me just write the procedure first. Plus 12 minus 4 root 2. This portion has gone because that's a 1. And 12 and this portion will go. What will remain with is 8 root 2 minus 4 root 2. So we get these which are outside. That will be 8. And then we got a minus 4. And then we just get our root 2. So 8 minus 4 will be 4 root 2. So that simplifies to that stage. Okay.
I have a question. So,
Yes, go on.
may I join late where you said where we are finding the rational number between 2 and 3? What rational number did you pick to be as the answer there?
Okay. You are saying between 2 and 3?
Those irrational numbers which you listed, because the question was like find the irrational number between 2 and 3. Now, for those there was root 5, root 6, root 7 and 8. Which one did you pick as the irrational number between which lies between 2 and 3?
So all of them, you can pick, if they have asked for one, just get one of those. All of them are rational numbers between 2 and 3. Okay? So if we are talking of a number line, if you have got a number line where you've got your 2 here and your 3 here, you have got root 5, you've got root 6, you've got root 7, you've got root 8. All those numbers are between here. That is because if you press on a calculator root 5, that will give you about 2.2. Root 6, that will give you about 2.4. If you get root 7, that will give you about 2.6. And then root 8, that is about 2.8. So all those numbers are between these two. Is that okay?
Yes. Okay, what if they ask that define the irrational number between negative 4 and negative 2?
So it's the same process. Assuming we have got no negatives, alright? So just get the 4 and the 2 first. So if you multiply these two numbers, what you are going to get is 8, isn't it?
Yes.
So root 8, now because they are negative numbers, put a negative in front. So root 8 is between negative 4 and negative 2. And then you can also subtract these two numbers, like multiply 4 by 2, that will give you 8 minus 1. So that will be root 7, but put a negative. So even negative root 7 is between those. And then you can add 1 to your 8, that will be negative. But if we say root 9 is a perfect square number. Okay. So it won't qualify in that case because root 9 will give us a 3, exactly a 3. So we can get negative root 10 because here the difference is 2 between 4 and 2. So you can add the 2, like if you multiply 4 by 2, that's 8, add the 2. So all these are between 2, they are between negative 4 and negative 2. Other questions?
Yes, sir. There's a question.
Yes, go on.
How can we show that
This one?
Yes.
Okay. So the first thing, before you even show this one, just write it in a proper form that is going to help you do it better. So conjugate it, or in other words, rationalize it. So rationalizing this, it will become root 2 minus 1, even down root 2 minus 1. So it's the same number, because this portion is a 1. The same thing over the same thing is a 1, so we are not changing the number. So 1 by what is on top, that will give us root 2 minus 1. And then what is down is the difference of 2 squares, so just get root 2 squared and then minus 1 squared. So this is root 2 minus 1. Root 2 squared is a 2, and then minus 1 squared is a 1. So that is the same as root 2 minus 1. 2 minus 1 is a 1. So this is the same as this. So I want to show that root 2 minus 1 is irrational. And how do you do that? Okay. So let me just try to clean up this space which is here. So when you want to show such a question that it is irrational, first assume that root 2 minus 1 is rational. So if you assume that it is rational, it means your root 2 minus 1 can be written in the form a over b, where a and b are integers, and then b is not equal to 0. So now you can take the one this side, that will be your root 2 is equal to a over b plus 1. So that will be root 2 is equal to a plus b over b. Now because this is an integer, a and b, remember we've said those are integers. Whenever you add two integers, the answer will always be an integer. And so what we are finding is this portion will be an integer. Okay, and then we've got b down. So an integer over an integer will always be rational. So what you are finding is this part is rational, but we know that root 2 is irrational, and an irrational number cannot be equal to a rational number. Hence, root 2 minus 1 is irrational. Now, get this, please get it well. If you were not already told that root 2 is irrational, first go show that. So you show that root 2 is irrational. After you have shown that root 2 is irrational, and then you reach this stage, then at this stage you are going to say, since root 2, which you already showed that it is irrational, cannot be equal to this portion, which is rational, then that is contradicting our assumption, and so the root 2 minus 1 is irrational. But most of the times, if you've been given like the addition of most of the times if you've been given the addition of of irrational numbers, or the addition of an irrational number and a rational number, they will tell you that given that root 2 is irrational, show that root 2 minus 1 is irrational also. But if they've not told you, you also need to show that this is irrational. You just even see by the fatness of the marks they've given. Okay. Is that okay?
Yes, sir. Okay, now say we don't rationalize this.
Okay, you don't want to rationalize it. Okay, what was the original number?
1 over root 2 plus 1.
So now we are making an assumption. Assume 1 over root 2 plus 1 is rational. So if it is rational, it means 1 over root 2 plus 1 can be written in the form a over b. Okay. So at this stage we can cross multiply. So what we are going to have is the a is multiplying root 2 plus 1, and that should be equal to b. Okay. At this point we can divide by a, so that would be root 2 is equal to b over a. I mean root 2 plus 1. We've just divided by the a on both sides. And then we can take the 1 over the other side. That will be root 2 is equal to b over a minus 1. And this is giving us root 2 is equal to b minus a over a, which is the same thing. If you are subtracting two integers, the answer is always an integer. And an integer over an integer is a rational number. And that can't be equal to an irrational number, which is here. Is that okay?
Yes, yes.
Alright, next question.
Sir, I have a question.
Yes, please.
I have a question. The question is goes like the 2
Yes?
over open bracket 3 minus
Ye
2. 3 minus root 2
yes?
close bracket then open 1 minus 2 then you are told to simplify actually bracket because I tried to rationalize the answer which was not being able to be simplified.
Okay,
So I
so
don't know what method can be used.
alright, so what we are going to do is we are going to distribute 3 by 1, that is the 3. 3 by that will be a negative 6 root 2. And then negative root 2 times 1, that will be negative root 2. Negative root 2 by this portion, it is negative root 2 by,
Don't, sir,
yes,
the negative root 2, the negative 2, not root 2. There must be 3, not 2.
which portion? Here?
Negative 2 root 2. It's supposed to be negative 2 root 3.
Okay. So this is the 3, right?
Yes.
Okay, same. Let's do the same. So we multiply. We are distributing 3 by the 1, that will be 3. 3 by the 2, which is there, that will be 6, and then root 3. And then this 2 by this 1, that will be negative root 2. And then this 2 by this portion, that will be negative, it will give us negative 2 root 6. Do you know how it is coming? The root 6. So multiply what is inside there.
So is it not supposed to be positive
Oh yeah, it's supposed to be positive here. Positive 2 root what?
root 6?
Yes. Okay. Now from this stage, the question was to simplify, isn't it?
Yes.
Minus root 2 minus 6 root 3 plus 2 root 6. Now the problem is simplifying a complex surd. This one which has got more than 2 terms in the denominator. So the question is, how do we simplify that one? Okay. So is it true that we can split this thing which we have here? Do you know that we can split it into 2 over 3 minus 2 over root 2 minus 2 over 6 root 3 plus 2 over 2 root 6. Is this true?
I don't know.
Okay, you don't know. So the thing will be here now. If you want this portion which we have here to go back to where we came from, remember, how do we work with fraction? Sorry. Imagine you've got a fraction. Let me just give an example. If you've got a number like 1 over 4 plus 3, Are you able to split this number when it is like this, in this form?
Is it plus 3x?
So you can only split if this thing is the same. So in this case, you can't split it the way it is like that. So you can only split when the denominator is the same, isn't it? Oh, we have forgotten. Like this number I've written here, 2 plus 3 over root 2 can also be written as 2 over 2 plus 3 over 2. Is it not so?
Yeah, but that is root, but
Yes. I heard someone speaking.
not a common. A common. These are common
Yes.
numbers, so you can add them.
Yes.
But you have not added the roots.
So what we are saying is we can't split this one the way it is. So what you do is you want to make sure that this thing which is in the denominator, we don't want it in the denominator. So you need to conjugate the down part. So we are going to multiply with what we can see down and go until the down part simplifies to the furthest point that we can reach. Okay. Because root 6, root 3, and root 2, there is no way that we can put them together. So let's go on and conjugate. So what we get, what is down, that is 3. Let's try to change the signs. So these are rare cases that we are going to find. That's a minus there. So let's first keep the top part the way it is. So our problem is to work out the denominator. Okay. So we are first getting what we can see here. We are multiplying what is there until it simplifies, and it will simplify. Okay. It's just that it is not that direct. So what you get is, first we get the 3. We multiply with everything that we can see there. So that will be 3 multiplied by a 3 here. That will be what? 9. And then 3 multiplied by root 2. What will be the answer?
Negative 3.
Is it negative? So we are multiplying this and this. And then again the same 3. So we've multiplied first like that. Again we multiply like that. We multiply it with that one, and then we multiply it with that one. So it's the same number that we are doing like that. Again 3 by that other portion, 3 by 6, that will be 18 root 3. Again 3 by negative 2 root 6, that will be negative 6 root 6. Again now we come to this part. Negative 2 by 3, that will be what? Negative 3 root 2. Is it? Are we fine with that?
Yes, sir.
Okay. Now just at this point, remember the main aim is this part which is on top is supposed to cancel out. Like the top portion is cancelling with the down portion because it's supposed to be the same thing. So just at this part, let me make this negative and this negative because it's a complex thing. Okay. So if I make that negative, it means when we multiplied this with this one, it was supposed to be what? Negative 9, right? Everything is just the same. I haven't changed anything. I've just put a negative there. Now we are multiplying root 2 by this. It will be positive 3 root 2. Again the root 2 by that. That will be negative what? Negative root 2 by root 2. Negative 2. And then negative 2 root 2 by this portion. What are we going to get? Negative what? Negative
root
6
6.
root 6. And then negative root 2 multiplied by that one, which is what are we going to get? Positive 4 root 6. Is that true? Are people following or someone is already lost?
That was supposed to be positive 2 root 12 because we are multiplying by the root.
Oh,
It's
yeah,
supposed to be to multiply that one in the bracket.
you are right. This is supposed to be 12. Yeah, like that. Again, we come to this one.
Then there we're supposed to have the 2 instead of.
Good. All right. So we come from negative 6 root 3 multiplied by this one. What are we going to get? Negative 6 root 3 multiplied by negative 3. Positive. Are we together or some people are lost already?
Sir, it's very obvious.
So that is a problem. That is a problem that arises, and these are rare cases, and I mean they are rare cases. And there's nothing to do. You just have to do that if you want to simplify. So just from here that you can see that some things will already be cancelling out. Okay, some things you start cancelling out just at this stage where we are, or some things will start adding up, and that will start simplifying. We go on, or we are lost.
No, we just need to get some questions.
So you go on simplifying like that until you reach at an extent where in the denominator at sorry, let me just remove that. So you reach at a point where in the denominator you are going to find something. Of course, on top it will be a complex thing because you are multiplying by all those things you are multiplying. But in the denominator, to give you a root of some two same thing, it will give you something like this. And then now you have to reconjugate it again, multiply again by the conjugate of what you are going to find again in the root. You continue going on until you reach to the answer, and that is rare. And those are few rare cases you find. Alright, next questions.
Tutorial sheet 1, question 10. Where we are asked to approve or disapprove maybe a sum of irrational and irrational number, whether it is rational or irrational.
You people don't have things like from quizzes, or don't have past paper quizzes or tests. You know, those tutorial questions. Okay, if you want to disapprove or if you've got root 2 plus 1, you want to disapprove or approve that the sum of an irrational number with an irrational number is always irrational. So if you add an irrational number with a rational number, the answer will always be irrational. It can't be rational. That is why for this question, remember we had the question which said prove that root 2 at which minus 1 is a irrational number. So this is rational, this is irrational. Whenever you're adding two numbers, irrational and irrational, the answer will always be irrational. And whenever you're adding two irrational numbers, the answer is always irrational. At the same time, when you add an irrational number with, a rational number with a rational number, the answer is always rational. You can prove that 2 plus 3 is equal to 5. So this is approved. Now, if you want to disapprove that it can't be irrational, you can just get negative 2 plus 4. That will give you 2. 2 is rational. If you wanted to disapprove irrational, then this is disapproved. So such questions were there to open up your minds, and I don't think you'll be troubled with. They know those are simple, so they want something. Of course, the tutorial is there to open up your understanding to research more. Mm. Are there other questions? It seems we know already binary operations and other. All right, go on.
How can you express 1 over
Yes, 1 over
1 minus root of 242?
1 minus root of, like that.
242.
Yes, like this.
Yeah.
Out
Yes, in the form of a plus b root of.
like that. Okay.
Yes.
So the first thing is let's rationalize the denominator. So we are going to change the sign, even down. So if we multiply this by what we can see there, we are going to get 1 plus root 242, and then divided by this multiplied by this is the difference of 2 squares, so that will just be 1 squared minus okay, root 242 squared, which will give us 1 plus root 242 over 1 minus 242. So this is the same as 1 plus root 242 divided by 1 minus 242 being negative 241. Is it true?
Yes.
Okay. Now remember, our aim is to write in the form a plus b root c. So where we can see a root, let's make sure that we have got a 2 inside. So what we want to write is 1 plus. How do we write 242 with a 2? So that will be 2 times what number? So just say 2 into 242.
121.
Okay. That is 121. And then we are dividing by negative 241. And then what is the root of 121?
11.
So that is 11 root 2 divided by negative 241. And then split them. That will be negative 1 over 241 minus 11 over 241 root 2. So that is the form that we wanted. Is that okay?
Yes, yes, sir.
So the binary operations, I've just seen questions on complex numbers and SURDS and irrational. Amases twaliyeshima nama binary operations.
Sir, yesterday you didn't answer my question. I asked the question on the sets.
You can ask it again.
I was saying that given that A is a subset of B, then we are taught to find A, B, A union A complement intersection B.
What are you saying? A what?
A complement intersection B,
Like this?
but not using the Venn diagram, because we know that sometimes when we are taught that B complement union A, it's the set will be A, but just showing what will be the answer,
Oh,
not showing the Venn diagram.
what was the question saying? So if they ask you to find, what was the question saying?
Given that A is a subset of B,
Uh-huh.
find A complement intersection B, but not using the Venn diagram. There was sometimes when you are using maybe if you are given the disjoint set, then you are taught to say find A complement, if A and B are disjoint, then A complement the answer will be B. But
Okay.
in that manner, just showing the set in that manner.
So is this question where you told exactly don't use the Venn diagram?
Yeah.
Okay. So and you can't run away from some things. Was it really stated don't use a Venn diagram? No.
try to simplify, but don't try to
Simplify.
so, so, so that means you can't answer this question without using the variable, right?
So something.
That's the thing I'm not very sure.
So you can't escape from some things if they give you something. Just like if they tell you move from the ruins, go to MLT. You can't escape from passing near the library or passing at UNZA. You can't escape. That is a pathway. So if this is A, this is B, and then the road is here, you can't say no because you can't escape from passing. What if there are lions here? You want to die? Is that okay? Okay.
Yes. So, okay. So the answer, the only way we can show the answer is just by using the Venn diagram. That's so.
So this is our A, this is our B. So A complement is everything outside A. Now, where does that intersect with the set B? So our set B is here. Okay. So that is it. So the A complement is going up to the outside. Is going up to the outside of that set. But because we're talking of where it intersects with the set B, we are simply getting the inside portion like that. Now, how do we describe that portion? Of course, we are not including the set A itself. So this one simplified further, it is simply B minus A. It is itself. You can't simplify it further than this. It is itself. I think if you wrote the first tutorial sheet for mathematics, such a question was there, and the final answer was itself. So you can't do anything. You don't have what to do. Yeah. All right. Other questions? Or we are already tired? We with.
Another question.
Okay, go on.
Let's go through this. Uh, you're saying that let A.
Uh
Okay, just a minute. Okay, let A be a
yes.
member of integers where A is less than 1,
So okay.
where X is less than
Just a moment. Is it given as a set notation?
yes, set notation form.
Okay.
Let A X is a member of integers where X is less than -1.
X is less than.
Okay, just write -1. Erase that T. -1 less than X less than or equal to 13 over 2.
Like that?
Yes, and B be equal to 2568. Then C be equal to 1264. Then there is also set. There is also set is a set of integers
Yes.
-3 less than X less than -4.
Less than what?
-3 less than X
Like this?
then less than or equal to 4.
Okay. So like
Be
that?
equal to less than yes.
Yes. Okay.
Then now we are talking on
Uh-huh.
then A intersection C complement
Is it everything complement or complement just on C?
on C.
And then
Then B now is A intersection C.
how is the intersection C?
A intersection C is in brackets.
Like that?
Yes,
Just those?
yes.
Alright. Now let's start with our A. Now please friends, what we need to understand is we need to be very careful when we are talking. Please note your universal set. This is a very important thing. First thing is understand your universal set. Otherwise you end up, at times we are just too used to the set of real numbers as a universal. Please don't. Alright. So now the first thing is we just put our universal set there. Our universal set is from -3 up to 12. And for security purposes, just put an open bracket there and then put a close there so that you don't forget. Because for our universal set, we are including 12, but we are not including -3. Now, the set A is running from -1, okay, let's say -1 here, to 13 over 12. 13 over 12 is about 6.5. So let's say 13 over 12 is, 13 over 2 is about 6.5, which is somewhere there. And for A, we are not including -1, but we are including 13 over 2. So this is our set A, right? Are we all fine with that one?
Yes.
So the complement then, since 13 over 2 is in A, the complement will not be there. So when we reach at the universal set, remember 12 is being included in the universal set. So like that. Now -1 is not in set A, so it will be outside the set A. And then up to there, but there we are not shading. So this is our A complement. Then our A complement is going to be from -3 to -1. This is open, this is closed, and then from 13 over 12 up to 12, where this okay, 13 over 2 comma 12, where we are including the 12 but not including the 13 over 2. So that will be it. Is that okay?
So yes, this is okay. Now, if we don't use this form, then we want to use the form of listing.
So you can.
Listing was on.
All right. For the first part, for A complement, you can't list. Is that okay? For the first question, you can't list. So unless the second question, you can list. The first question, you can't list. Why? Because just in this range, which is here, just from here up to here, from -3 to -1, you just have a countless number of. There are a lot of numbers whereby you can't list. So it is a range. So whenever you've got a range, please, you can't list. So let me just show a simple example. If A is from 1 up to 2, okay, a very simple example like that. And then you have B, which is 1 and 2. These are two different things. For this set, you can't list the elements. You are talking of all elements from 1 up to 2. Unless if they told you this is a set of integers, then you can list, because integers between 1 and 2 is just 1 and 2 itself. And we are not even including the 2. So in that case, it will be only 1. But if it's a set of real numbers, you can't list this set. That is because between 1 and 2, you have got 1.0, 1.01, 1.001, 1.0001, and they continue like that up to reaching to you can't list them. But for this one, Very simple. Listing is just 1 and 2. Hope that is clear. Are we together?
Yes.
Okay, now we can go to question B. So for question B, we want to find A intersect C complement. So we can first get our set A. Our set A is running from -1 up to 13/2. So we are not including -1, but we are including this portion. So this is our set A. Now let's go to our set B. Our set B, these are elements. This is not a range. So in the set B, we've got 2, we have got 4, we have got 5, we have got 6. 13/2 is about 6.5. So that means our 8 is going to be in front here. So the set B, we can't show it as a range. So those are elements. So those are put in red. That's our set B. Oh, sorry. On 13/2 is not part. Okay. That. So that is B. Everything, all dots you are seeing in red, that's B. Now you are talking of A. Okay, the question didn't even talk about B. We are talking of C. So I'm using the wrong information. Okay. Let me just remove that. I use C because we might error. Okay. Now for C, it has got elements 1, 3, 6, 9, and also 12. So I'm going to use blue to represent the set C. Okay, so that is my set C. Now we are looking for A intersect C complement. So now what is outside A but not in C? So you can see that A is starting from here. As we go, when we reach 1, we don't want anything that is in C. So when we reach 1, we are going to skip. We are going to be put an open circle. We continue moving. When we reach 3, we are going to skip. We put an open circle. We continue moving. When we reach 6, we are going to skip. We put an open circle. We continue moving. When we reach 9, we don't want that because it is in C. We skip. And then we continue moving. When we reach, okay, but we are not even going to reach to that far end because we just want what is in A but outside C. So we are just going to end at this point. We are going to end at this point. So everything this side won't be there because it is outside the set A. So this portion is out. But remember 13/2 is in the set A. So we are going to include it there. So this is A intersect C complement. So therefore A intersect C complement is going to be, we started from -1, we didn't include -1, up to 1, we didn't include it, and then we continued from 1 up to 3, and then we continued from 3 up to 6, and then we continued from 6 up to 13/2, and then 13/2 included it. So we put that. So that is the answer.
Sir, that is confusing.
How is it confusing?
The limits you have for C is from 1 to 10. So if they mean now C complement, don't they mean that you have to find the intersection where A is intersection with members which are not part of C?
Okay. So now, I've now looked at the question. So look at this one. That is what? That's an integer. And because that is an integer, that even disqualifies us writing even A complement. I didn't see that to be an integer. So I was assuming that to be a real number. Please, that is an integer. So just starting from the first question, let me repeat that. That's not a real number, it's an integer. So this is where we need to be very, very careful when you're answering questions. Okay. So these which you've been given are all integers. There's no real number. Even this one, even the universal set itself is not a real number, it's an integer. So if you are talking of integers from -1 up to 13/2, what we are talking about are numbers from -1, but because these are integers, integers are all numbers, either negative or positive. But see, we are not including, because we are saying -1 is less than x, so we are not including the -1 itself. Okay. So it means our set A, we can also rewrite it as, we are not including -1. And this is an integer, and we know that integer are all numbers without decimal points. So from -1, if you are going forward, what is the next number? Because we are not including -1. What will be the next number? It will be 0, and then you go to 1, to 2, to 3, to 4, to 5, to 6. Now, just this statement is by itself a disqualification. You can't have an integer there and at the same time this is 13/2. 13/2 is not an integer. So this is a contradiction. So where did you get your question?
From the quiz they wrote last year.
I think I've got a paper for quiz. So this is a contradiction. 13/2 is not an integer. So if it says we include 13/2, then we are also including what is not an integer. Okay. So because the question said we include 13/2, let's put it there, but we know that 13/2 is not an integer. And then B is fine, the universal set is... Pardon?
I'm saying someone explained to me to say that they took it as 6. And since the they took it as 6.
So yeah, we should have taken it at 6, but this symbol should have been less than, and we should have taken only at 6. So it should be between those, but we shouldn't have been saying less than or equal to. So that was an error on that one. So for the universal set, then the universal set is also starting from -3, but we are not including -3, so we're starting from -2, -1, 0 up to 12. So you've seen this one, we are including it because 12 is also an integer. So this symbol which was here, that was the one which was just not alright. So if you are talking of A complement, you want things which are in the universal set but not in the set A. Now if you see in the universal set, we have got -2, -1, they are not in the set A. And then you have got, if you go to 0, 0 is also in the set A. And then of course here we've got numbers from 0 up to 12. So we are going to remove 0, 1, 2, 3, 4, 5, 6. So we are removing all those. So we are going to continue from 7, 8, 9, 10, 11, and 12. So that will be the A complement. Is that okay? So from that one now we can go to A intersect C complement. So we want what is in A. So you can get your set A. Our set A, we know that is the values from 0, 1, 2, up to 6. And then we want to intersect it with what is outside the set C. Now this is our set C. So what is outside the set C, we are taking with consideration to the universal set. So let's go to the universal set. We have got -2, -1, 0, but we are going to remove from the universal set 1, and then we are going to go to 2 because 2 is not in C, and we are talking of C complement. And then we are going to remove 3. We have, in C we don't have 4 and 5. So 4 and 5 are in the complement. And then we have got 6, so we are not going to put it. And then we have got 8 outside this C. And then 9 will be removed. Okay. And then we have got 10, which is not in C. 11 is also not in C. But 12 is in C. It is also in the universal set, so we are not going to put it. So these are the numbers which are outside the set C, but they are in the universal set. Now, where do they intersect? So which numbers can you see in common in both of these brackets? So we have got 0, and we also have a 2. Because in here we don't have a 1, whereas there we have got a 1. So the intersection is simply 0 and 2. And notice the brackets which we are using. All these are elements. Is that okay?
Yes.
And then the last one, which is the B minus A intersect C. So we can first get the set B. We know the set B is 2, 4, 5, 6, 8. And then we can get, we are saying minus A intersect B. Now where does A intersect with B? So this is our set A. This is our set B. Now what is in common between those two? So 2 is in both. So we're going to say 2. And then we go to 4. 4 is in both. And then we go to 5, which is in both. And then 6 is in both. So these are the only elements. Now we want the elements which are in here, but remove these. So we are removing 2 from this set. We are removing 4 from this set. We are removing 5 from that set. We are also removing 6 from that set. So all we are remaining with is an 8. So that is the answer. If you wanted, you could have used another formula where you say B minus A intersect C means B intersect A intersect C complement. And then this is the same as saying B intersect A complement union C complement. And then, but this would have been even much difficult. Okay. Should we end here, or there is another question? Is there another question? Or
There's only one question.
okay, go.
One question for one hour operation.
All right. If there are people with questions, you can bring them. Are there questions on binary operations?
Yes, President. Okay, given an operation,
Yes.
uh, A plus B minus AB, that's A aspirate B.
Pardon?
That's the operation we are given.
Okay.
That's the operation we are given, that A aspirate B.
Yes.
Then we are told to show if that is commutative and associative.
All right. So we have got A star B is equal to A plus B minus AB. Is this associative? Is this commutative? Now, when you are talking about first, let's start with commutativity. So if you are talking about commutativity, what you want to show is that A star B should be equal to B star A. Okay. But we already know that A star B is equal to A plus B minus AB. So if we take B star A, that will be equal to, now we have changed. If you've got the first number, star the second number, you are going to get the first number, add to the second number, and then subtract the product of the first number with the second number. Now in this case, our first number is b, so that will be b plus the second number is a, and then minus ba. Now of course we know that a plus b is the same as b plus a, so this is the same as saying a plus b. And then minus, of course we know that ba is the same as ab, so what we are saying is a star b is equal to b star a. Then this is commutative. Okay, is that fine? I'm not hearing ladies speaking. Are they together with us or they are somewhere else? Are we together on that one?
Together, sir.
Okay. Now, if you want to show if it is associative, associativity brings in the third term. So what you want to show is a star b star c is going to be equal to a star b star c. Now, what is this saying? If you work with the first two terms, and then the answer that you get come to work with it with this term, it should give you the same answer if you get first to work with the first two terms, and then the answer that you find star with the third term. So that is associativity. For example, if you've got 1 plus 2 plus 3, even if you first add the 2 plus 3, it should be the same if you add first 1 plus 2 and then add the 3 at the end. So this is associativity. So what we want to work out is that same procedure. So let's start with this portion. So a star b star c is equal to, first we have a. Let's first work with that, what is inside the brackets. Now we know that if you have got b star a, b star c, I mean, you are working with this portion. The first term is what we are going to put there. So in this case, the first term is b, and then add to the second term, so plus. In this case, our second term is our c, and then subtract the product of the two terms, so minus bc. So that is it. So at the same time, this now will act as one term, and then we take it and start with the a. So now that will be equal to, now our a in this case is the first term, so we are going to get there. Our first term is a, and then we need to add to the second term plus. The second term now is b plus c minus bc. Okay, and then now minus the product of the first term and the second term. Now in this case, the first term is a, the second term is b plus c minus bc. So I can distribute that. That will be a plus b plus c minus bc, and then we can work with those. That will be minus ab minus ac minus, plus abc. Are there anything that we can simplify here? I don't think there's anything that is common. This is a, this is b, this is c, this is bc, ab, ac. Very different things, so we can't simplify. So now we can go to a star b and then star c. We know that a star b is giving us this portion here. So we are going to get a plus b minus ab, and we take this star c. So the whole of this portion is going to act as the first term. So that will be, remember, the operation is in the first term. The first term we are going to get is a plus b minus ab, and then add the second term plus, now in this case the second term is C, and then subtract the product of the first term and the second term, that is minus the first term in this case is A plus B minus AB. We are multiplying with the second term, which is C. Let's distribute. That will give us A plus B minus AB plus C, and then minus, we are distributing C by A, that will be AC. C by, remember this negative is also distributing to everything which is here. So negative times this B, that will be negative B, and then negative B now multiply with the C, that will be negative BC, and then this negative distribute with that AB, that will be positive, and then now with the C, that will be positive ABC. Now is this the same as that? So what we can see is we have got A there. Okay, we have got A, we have got A, we have got B, we have got B, we have got C. Do we have C here? It is there. We've got negative BC, we have got negative BC, negative AB, negative AB, negative AC, negative AC, ABC, ABC. So we can see that A star B star C is equal to A star B and then star C. Okay. So having shown that,
So it's just saying that
yes,
here on the here where we are multiplying
yes, yes.
when you restate this, it's negative.
Okay, just a moment. Okay, you can switch off the mic now. Okay, so we have got A, which we've written there, we've got B, which we've written there, we've got negative AB, which we've written there, and then we've got E plus C. Now minus A plus B minus AB times C. So this C can also be written in front like that, and then that will be A plus B minus AB. So you can also write, this is the same thing. Multiplication is commutative. AC is the same as CA. Okay. If we say negative AC, it's the same as, sorry, negative. Okay. All right. Is there another question? Let's hope now we are ready for the quiz. Are we ready now for the quiz?
The student is already
All right, so tomorrow we are going to continue revising. Of course, we don't have mathematics tomorrow, and we don't have mathematics. Do we have people who are writing the quiz tomorrow or on Tuesday?
that's right tomorrow.
Ah, all right, that's nice. What time are you writing? Okay, so what time do you think we should make another lesson so that we do the final? Or we end here, it's fine, eh?
It's fine. Just send solutions for the quiz you prepared.
The solutions are in the group I sent yesterday.
Alright. Can you send us? I know you're not in the paper. Maybe we are just getting it.
No.
I would like to see how it's done.
Okay. Now, because you didn't write physically, so the marking was marked differently. Unless those people who brought the papers physically, they are able to see where they went wrong. But be very careful. At times here, they'll just mark the last answer. And they've done that a lot. I've seen a lot of papers which they've marked where the procedure is quite alright, but they just look at the final answer is wrong, and someone maybe is they are tired or they are moody or they are pregnant or something like that, they just mark wrong. Okay, the lesson ends here. Thank you so much. Have a good night.
Mr. Mans,
Yes, sir.
before you go,